Students, this will walk you through what's called the Right Triangle Toolkit, also known as the My Best Friend quiz. You're going to be required to fill out these blanks yourself on quiz day, as well as do one sample problem of each. Let's do one together. Ready? It says, if you have a right triangle with two sides and you need a third side, what do? Two sides, third side, Pythag. That's where you guys know that leg squared plus leg squared equals hypo squared. That's when you have two sides and you need a third side, also known as a squared plus b squared equals c squared. But that's my preferred version right there. So let's do a sample problem here. So we have here a right triangle, and we have one leg. So let's go ahead and label here. One leg is 6, the other leg is unknown, and then here is your hypo. And we want to solve for the unknown leg. So first we write down our equation, which is leg squared plus leg squared equals hypo squared. Now we circle plug chug. So leg squared is going to be 6 squared. Plus the other leg, that's our unknown, equals our hypo, that's 9 squared. Now we solve, and of course 6 squared is 36. Now we're going to minus 36 both sides to get x by itself. We're going to have to borrow. Okay, so we have x squared equals 45. So to backtrack a square, of course, we square root. And here, 45 is not perfect, so we have to factor. That's going to be 9 times 5. And then there's the 3 and 3. So what comes out is going to be a 3 square root 5, and the 5 stays under the radical sign. So the final answer here for this leg is going to be 3 root 5. So that's an example of Pythagorean theorem. Again, when do we use this? We use this when you have two sides and you need a third side. Next one is if you have a right triangle with a 45-degree angle and you're going to use a missing side, that's where we use the 45, 45, 90 table. 45, 45, 90 table is the legs are equal, leg equals leg. And the hypo is whatever the leg is times the square root of 2. So 45, 45, 90, leg, leg, leg root 2. 45, 45, 90, leg, leg, leg root 2. Now let's do an example problem together. So here we know our legs are equal. And the hypo is whatever the leg is times root 2. So this reads like this. Something times root 2 is 6. That's how that reads. Something times root 2 is 6. And you should recognize that something is going to be 3 root 2, because 3 root 2 times root 2 looks like this. Root 2 times root 2 is 2. 3 times 2, therefore, is 6. So we know here that's going to be 3 root 2, and whatever one leg is, the other one is as well, 3 root 2. That's our second tool. Our third tool is this. Is if we have a right triangle and either a 30 or 60 degree angle, then we're going to use the 30, 60, 90 table. In the 30, 60, 90 table, everything goes back to the short leg. So you start just by writing the short leg. 30, 60, 90 equals short leg root 3, and then the short leg times 2. So 30, 60, 90, short leg root 3, short leg times 2. 30, 60, 90, short leg root 3, short leg times 2. So everything goes back to the short leg. It's really important you identify that. And to go to the hypo, you times by 2. And to go to the long leg, you times by root 3. So sample problem. So in this problem, let's label X is going to be our short leg. That means to go to the hypo, we times by 2. To go to the long leg, we times by root 3. Let me keep my colors straight here. Okay, so this reads something times 2 is something. We can't do that. So it's something times root 3 equals 12. That's what you're thinking. Something times root 3 is 12. You should recognize you need another root 3. Root 3 times root 3 is 3. And then 4 times 3 is 12. So our short leg is going to be 4 square root of 3. Times that by 2. And only the outies talk to each other, so that's 8 root 3. So that right there is 3 of your 5 right triangle tools, 3 of 5. Now here's the other 2, SOHCAHTOA and inverse SOHCAHTOA. On the left, if you have a right triangle and an angle and you want to find a missing side, you're going to do SOHCAHTOA. On the right, if you have a right triangle with 2 sides and you want to find a missing angle, you do inverse SOHCAHTOA. So to find missing sides, it is sine of theta over 1 equals opposite over hypo. That goes with the acronym SO. Cosine equals adjacent over hypo. That goes with last one, tangent of theta equals opposite over adjacent. That goes with TOA. Let's do a sample problem for SOHCAHTOA. If here we start by sweeping the theta, theta is the angle we're working with. We label, this is opposite. So in this triangle, we have the opposite, and we want the hypo, which is our x. We have an OH combo. You look up here, we know OH goes with so we copy exactly that down. Sine of theta over 1 equals opposite over hypo. So now we're going to circle plug chug. Sine of theta, that's 48. So we write sine 48 over 1. Let's bring it in real close so you can see it. Equals, our opposite is 13 over our hypo, which is x. We're going to cross multiply, and we get sine 48 times x equals 13. Now you can't grab a calculator. X is not by itself. So we have to divide by sine 48. So we see to find x here, we have to do 13 divided by sine 48 degrees. That's how you find x in this case. So on your calculators, most of you know how to use your own calculators. I'll show you on my computer calculator. We're going to go 13 divided by, I have to do 48 sine, notice that up at the top, equals, let's take it to the second decimal place, 17.49. So 17.49 is my hypo. As an example of you using SOHCAHTOA to find sides. Now to find angles, we use what's called inverse sine, cosine, inverse cosine, inverse tangent, and it looks like this. Inverse sine opposite over hypo will give me the angle theta. Remember, theta we use as the variable for an unknown angle. Inverse cosine adjacent over hypo gives us the angle theta. Inverse tangent opposite over adjacent gives you the angle theta. So let's take out our two examples here. Okay, so here, if that's our angle theta right there, that makes 10 the opposite, and that makes 20 the adjacent. I can see right now that's an OA. So I'm going to go inverse tan opposite, which is 10, over adjacent, which is 20, gives me my angle theta, which is right there. So in my calculator, that's 10 divided by 20, inverse tangent. Check your calculator, you should get the same thing. I get 26.6, and we're going to round up to 27 degrees. So this theta unknown right there is 27 degrees. If I want to do this theta, I see what I have. That's the opposite, that's adjacent, that's hypo. Look at what you're working with. We're working with adjacent and hypo, that's inverse cosine or arc cosine. So we do inverse cosine, adjacent, 12 over hypo, 19, gives us our angle theta. So here on our calculators, we're going to go 12 divided by 19, inverse cosine. Notice I get 50.83 degrees, which is approximately 51 degrees. So this right here is 51 degrees. Make sure you're able to do this on your own calculator and you're familiar with it. Once again, you're going to have to be able to fill out this entire sheet, both the top with the tables and charts, and do one example down below. The examples will be different than what's in your packet.